9.6, looking at how to solve right triangles in our trigonometry. Okay. So our essential question: when you know the lengths of the sides of a right triangle, how can you find the measures of the acute angles? Right. So we're looking at our inverse trig functions. Right. So ratios are used to find the missing angles when only side lengths are given. So the idea here, if you go remember what we talked about in 9.4, I went over you plugging this in the calculator, right? And I'd have like the sine of x equals, and I don't even know if this works, I'm just putting numbers in here, 5/7. All right, so I'm looking for x. So I need to do the opposite of sine. Same way if I had 2x equals 8, I divide by the 2 because that's opposite of multiplication. I need to do the opposite of sine here. Right, so when we're looking at the inverses of these, we write them as sine -1, cosine -1, and tangent -1. Okay. So that's the, that's the button that you're looking for on your calculator. Right. So then some examples. Right. Example 1 says use the calculator to approximate the measure of angle A to the nearest tenth of a degree. Right. So I have angle A here on A. I look at what sides I have to figure out what trig function I need. So I have opposite and adjacent. So I'm using tangent. Okay. I'm looking for A. And then tangent is opposite over adjacent. So 30/20. So then I'm going to do that in my calculator, and I'm going to do 30 divided by 20, or actually, it depends on your calculator, right? You're going to do the second tangent, 30 divided by 20, right? Which should get you 56.3, all right? Some of your calculators, you may have to do 30 divided by 20 and then hit the equal sign before you do the inverse of the tangent. And again, I think I said second because of the calculator I was looking at. Some of the calculators it's shift or something else, right? So if you have questions on how to plug it in your calculator, make sure you're looking at that the video on 9.4 where I went over how to do things on the individual calculators. Then B, again, we're looking for A. All right, so here we have the opposite and the hypotenuse. Okay, so that's our sine. So I have sine of A equals 14/26. Okay. So I'm doing the shift sign of 14 divided by 26. Gets me that A is 32.6. And then C, I'm looking at A, I have the adjacent and hypotenuse. So we're doing cosine of A equals adjacent over hypotenuse. And when I do use my calculator, I will get 51.3. Then example 2 says let A and B be acute angles in two right triangles. Use a calculator to approximate the measures. Angle A and B to the nearest tenth of a degree. So sine of A equals 0.76. Right. So here the 0.76 is taking the place of this fraction. Right. So if I 30 over 20, I can divide that and get my decimal. Same with 14/26, 10/16. This works. Realize it depends on the number. Some numbers will not work. But like 30/20 is more than 1. Both of these are under 1. That doesn't really matter. It can affect some things, but in general, if they're giving it to you, it should work. Right? So here, instead of putting the fraction in, where I would put the fraction, I would do 0.76. So the second sine 0.76, plug that in, and I get 49.5. If you're using a calculator where you need to do the fraction first, then you just need to put the 0.76 shift and sign button. and that should give you the answer. So here, do the same thing. I'm just using 0.17 cosine instead, and that should give me 80.2. Then flipping the paper over, all right, we have 4 problems on the back. All right, these problems, because we've now gone over everything I can look for in my right triangle. So these 4 problems are looking at solving for every part that's missing. Okay, so I need 3 parts. I need the 90 degrees, okay, and then I either need 2 sides, like in B, or an angle on a side, like in A, all right, to be able to solve for the other stuff. All right, there is stuff you can do if you have less than that, but that gets into higher math levels. All right, so for what we're doing, I need those 3 things. So when I'm looking at A, look at what you're looking for and what you need to get there. Right, I have PQ, which is here. I have QR, which is here. Right, and I'm going to use trig functions to solve those. I also need P. Right, but my triangle adds up to 180. So in this case, I can just do subtraction to get that. Right, this is 90. These 2 have to add up to 90. So if I subtract, I get that P is 53. Right, since I have that first, when I'm setting up for X and Y, I can actually use either of those. But I suggest always using the stuff they give you if you can. That way, if I did something stupid in my subtraction here, right, and I did 0, like the 0 minus 7, and I wrote 4 instead of 3, right, it doesn't mess up my other problems. Right, so I suggest using what they give you, but if you switch it around and use this, it would work. Right, so for my X, that's my opposite side, right? And I have the hypotenuse. So opposite and hypotenuse, I'm doing sine. So I have the sine of 37 equals opposite over hypotenuse. Right? So here I'm multiplying these, and I'll get 13.2 for PQ. Y, I'm my adjacent and my hypotenuse, so I'm doing cosine of 37, and I have y over 22, and when I plug that in, again doing multiplication here, I have 17.6. Okay. And same way I was saying with the angle, like I could use tangent with the 13.2 and the 22, but then if I made a mistake on the 13.2, it's going to make a mistake on the QR, so it's safer to just use what they give me. Right, now here, I have the 90, I have the 18, and the 11. Right, so P and N, I need to use trig functions to find them. So if I look at 18 and 11, I can pick either one of these. Right, this is if I use N, this is opposite and adjacent. If I use P, this is opposite and adjacent. So either one of these would be tangent. Right? So the tangent of P would be 18 over 11. The tangent of N will be 11 over 18. Okay? So this is what we went over on the front. I'm going to take the inverse tangent of the division here, of this divided. Depends on how you do that. Depends on how your calculator. That should get me 58.6. Right? And it does say up here nearest tenth. Okay, if this I didn't need it, so we just didn't put it. But here I do want to go to the nearest tenth. And I can use this, or I can subtract based on my other 2 angles to get N. Either way, I should get 31.4. Okay. And now B, for PN, you actually have a couple options you can do here as well. You can use your trig functions. I could use either of these and then use sine or cosine, depending on what I picked. If I want to stick with using what they give me and not something I've already solved, then I would do Pythagorean theorem. All right, so 11 squared plus 18 squared equals my x squared. All right, square both of these, add them together, take the square root, and I'm going to get 21.1. Then C, I have the 51 and the 14. So subtract to get my V, and I get 39. For MD, and I have opposite and adjacent, so I'm going to be doing the tangent of 51 equals 14 over x. So here I'm dividing the 14 by the tangent of 51, which gets me 11.3. And then for VD, I'm doing the sine of 51 because I have opposite and hypotenuse. So I have 14 over h, again doing division, and I get 18.0. Okay, and when I put that in, when I plug that in, I get, oh, wrong number, 14. All right, I get 18.01463, all right, which is why we put the 18.0 here as opposed to the 53 here. This is just all zeros. There is stuff after that 0.0, which is why I included it for the nearest tenth here. Then D, all right, again, back up to one like B. I need to use trig functions to find UT and, oh no, to find U and S. And then X, I can either reuse those trig functions or use my Pythagorean theorem. So I'm going to look at U first. I have sine of U, opposite over hypotenuse, which is why I did sine. So then use my inverse sine with that, which will get me 17.7. So then when I look at S, I now have adjacent and hypotenuse. So I'm doing the cosine of S, which is over equals 723. And again, if I subtract this, right, I should get the same thing, right? I have 90 here, so these two have to add up to 90. So if I do 90 minus 17.7, that will also get me the 72.3, right? And then here I'm actually looking for, this says US, I'm looking for UT as my third part. If I set up Pythagorean theorem, right, this is my hypotenuse, so that's by itself. So 7 squared plus x squared equals 23 squared. So I square both of these. I'll subtract the 49 and then take the square root of that, which gets me 21.9. And that is my work for those different problems. Let me solve everything in the triangle with 3 of my parts. Right? And again, you can switch things around and do some different ways to solve them. Generally, what I showed is solving them without using something I already solved for.